Welcome, everybody. Thank you for coming. My name is Chrystian. I'm an engineering manager, and I work at Comcast. I work in the office in Philadelphia, where I work on the Xfinity app, where some of you might use it. You can control your gateway, set up your internet security, set up your Wi-Fi network, cameras, sensors, all cool stuff. And today, I'm here to talk to you about good practices to reduce your app size. I'm going to tell you a little bit about the rationale why is reducing your app size important. Talk to you a little bit about WebP, what it is, and the value it provides. Also, I'm going to be telling you about Google R8 code shrinkers, play feature module delivery, how you can monitor your app size changes over time. I want to justify, right, why is reducing your app size important? Apps keep growing in size. You know, we add more features, more images, more onboarding materials, and the app keeps increasing in size. And for us, and for myself, like, have a cool foldable phone, like I think 512 gigabyte storage. Downloading an app, it's not a challenge, right? Like I can download it and I can store it, and I'm not too concerned about how much space an app uses in my phone. But a lot of the users, especially in the developing world, don't have that luxury, right? They might have phones with 16 gigabytes of storage, 8, maybe even less if they keep an older device. So reducing the app size is super important. It's an accessibility, due to accessibility reasons too. And Google Play also has a 150 megabyte binary size limit. Many companies, including Segment, have done studies about the impact of the app size increasing over time. For instance, Segment did this study where they looked at the APK size. They purchased an app called Mortgage Calculator Free, and they artificially inflated the size of the app to see the impact on downloads. And they found a linear decrease of downloads by each megabyte they added, right? So users were less likely to download the app the larger it was. The Google Play developer team did a study too, and they realized that smaller APK sizes correlate with higher install conversion. Your download completion rate of an app of a size of download size of 10 megabytes is 30% higher than that of an app that is 100 megabytes, right? So users are more likely to download the smaller app than the larger app. And again, this is far more impactful in the developing world. India, Brazil, India, Brazil, other developing countries, as opposed to here, for instance, in the US or Western Europe. As I was talking about, a lot of the apps keep growing, right? We keep adding amazing features. I know Gmail, for instance, this comes from Sensor Tower, and it's specifically about iOS, but you know the same applies to Android in general. For instance, the Gmail app has grown 19 times since 2016. Other apps like Instagram about 6 times, YouTube 5 times, right? So apps keep growing over time. So I'm here to give you ways to prevent that from happening to your app. There has been many studies, and for instance, this one from the Manifest about the top 3 reasons why people delete their apps. Right? The first reason is the app wasn't used. Totally valid. App didn't fulfill needs. You downloaded an app, and this is not what you wanted. It's not what you expected. It's not useful to you. You remove it. But the third reason is lack of phone storage space. Right? You take a lot of pictures, videos. You are filling up with video games in your phone, and you start making decisions of which apps you want to keep or not. And as I'm talking about that, I also wanted to illustrate, right? We talk about download size and install size. When an app is delivered, when you see the app on the Play Store, and I have a screenshot here of the Xfinity app that I worked on, as a user, you see, oh, for my Pixel 6, the Xfinity app is 90 megabytes. But does that mean that once I install the app, is it going to occupy 90 megabytes in my device, or is it just the download size? It's just the download size for reference, right? The apps are delivered as APKs, and an APK is just a zip file. You can rename an apk.zip, and you can open it with a zip tool. So the apps are compressed. So what the user gets transmitted from Google Play to their device is a compressed zip file. Once the device is installed into your phone, it gets decompressed, gets a little bit larger or much larger, depending on what type of content your app has. For instance, images and other things. And also, your app will be compiled into machine code once it's already installed in your phone, right? So later on, the app size will increase a little bit. Once it's installed, you can see how much it occupies on your phone. Here I'm showing how much the Xfinity app uses in my personal phone. And as you can see, app size is 188 megabytes. So if you remember from the slide before, it was 90 megabyte download. So it more than doubled in size just by uncompressing it. Also, the app is using things like user data. So we are storing information about you, right, like databases, other things that as a user you might create. Maybe you create videos, right, pictures, and all of that included in the app that you took using the app, so that gets included there. Also cache, things get cached too for faster usage of the app. So in total, the app went from download of 90 megabytes to once it's in my device, it's 203 megabytes. So now we know, right, app size, apps keep growing, and it has a big impact in how they grow. So how can we solve this problem? And the easiest solution we have to solve this problem is using WebP. A lot of our apps have a lot of visual aspects, visual images, onboarding information, right? It's very visual, and images take a lot of space in our phones. Google created an open source WebP, which is this amazing image format that provides, on average, a smaller size of compared to a PNG, which is the typical asset that design teams will deliver. So WebP is 26% smaller than a PNG. WebP supports lossless and lossy compression, and I'll talk a little bit about that further on. And Android has native support for it since Android 4.0. WebP does have some downsides. Figma, the tool that many of your design team uses for creating imaging, does not natively export to WebP. So your design team may be reluctant to change their workflow just to provide you WebP files, right? They will have to install a plugin or do a manual conversion. Also, iOS does not natively support WebP, right? So you cannot use the same format across both platforms. On iOS, an equivalent to some degree format is .heic, and it's great at compressing images like pictures, but not so good for vector art, right, or drawings you might make. It's not as good, so it's not something that can be recommended either for all cases. Versus WebP, which is, in my cases, I have converted thousands of images. It's always better, right, than a PNG. There might be some edge cases, but in general, it's perfect. And some tools like Adobe Dam, where you can store pictures online for your app to retrieve, does not yet support it, right? So there's some nuance there. At Xfinity, I worked on this. We had this picture that was given to us. It was of a person using one of our products, a security camera. And the file was 1.6 megabytes, right, as it was provided to us, which is huge. I applied lossless conversion, meaning lossless, nothing gets lost from the conversion from the PNG to WebP, and that netted me a file size 46% smaller, so around 800 kilobytes, right? And then I further optimized the image by applying 80% encoding quality loss, which means the lossy type that I talked about. So the image became much smaller. And in the end, the file was 3% of the original 1.6 megabytes. So it became 48 kilobytes, which is very reasonable. And how do you convert to WebP? It's super easy on Android Studio. You can right-click on any image you have that is PNG, and right-click and scroll down, and you'll get the option to convert to WebP. You click on it, then you get presented with this alert dialog that gives you the options that I mentioned. Lossy encoding, where things and quality will be lost, and lossless encoding, where nothing gets lost. Easiest thing to do is always to use the lossless, because you don't need to get it validated again by your design team, right? Nothing gets lost, quality remains the same. Also, you don't need to do this by each file, because the first time I did it, I started converting files manually, and I thought, gosh, this is such tedious toil work. Turns out the great people of Android Studio have created a batch process for this, so you can go to your drawable format, just right-click on it, convert to WebP, easy. Very, very easy to convert thousands of assets to WebP. And I have a video of how that works, right? So you saw the alert dialog. Here you're presented with the original file on the left, the PNG that I'm putting to WebP. And I am applying lossy conversion, as you can see by the scroll that I'm doing. I'm at 99% there, and the image is already 242 kilobytes. What's in the center that might be a little bit hard to see is what is getting lost from the image, right? The lossy, what is getting lost. And as I go further in compression, I'm applying a 99% compression. You can see quite a bit is lost, and maybe in the video it's not as clear, but the image is a bit pixelated. But you can play around with it, and it has a lot of power. You get a very good visual feedback of what changes and what is lost. Ideally, though, most assets should not be included in your binary. Ideally, you should be retrieving your images and whatever you show on the app from a CDN, right, from a network request that you're pulling that file just when it is used. So it doesn't increase the size of the original download. So you can host it on your CDN or other services. Or you could use Google Play on-demand delivery, which I will be discussing in a few minutes. And finally, I worked on this conversion of all of our assets from PNG to WebP on the Xfinity app. And before, when we had the PNG files, the install size on my Pixel 6 was 92.9 megabytes. After I converted all of our assets to WebP, the download size got lowered to 82.9 megabytes, so around 10 megabytes. 10% size reduction of our binary just by a couple of clicks. So it's amazing, and it can have massive impact in your app for a very low effort. Another way to reduce your app size is using code shrinkers. And code shrinkers are tools that help you reduce your code base size. They remove unused or unnecessary part of your code. They optimize for better performance your app. They obfuscate your code to get better security. And you might be very familiar with them. We have essentially on Android 2. We have ProGuard, which had been there since the beginning. It's open source, and it's very widely used in the Java ecosystem. And a few years ago, Google introduced R8, which is Google's own code shrinker, and it offers more efficient code shrinking specifically for Android projects. Here's how you can enable R8. You can go to your build gradle.kt file, and you can add minify enable, and you can set it to true. You can also add shrink resources. Shrink resources is technically not part of R8, but often you do two together. So minify enable is R8. And how does R8 work is that it removes dead code that is never executed in your app. It does class merging. It merges classes that are not used independently. It does field and method inline, so it will arrange your code for things that don't have to be separate. It will do a bit of string constant folding, and it will do type inference to reduce unnecessary typecast. So you're getting a lot of benefits by just turning on that little line of code and setting it to true. Minify enable true. Furthermore, shrink resources, which is not part of R8, but it often goes in conjunction with it, will remove images that are not used in your app, layout files, strings, colors, animations, fonts, and XML files. Again, this just removes things from your app that are not needed, right? You are adding code or adding features that you are not using. This will remove them automatically for you. R8 does also give you a benefit. It provides code obfuscations. So it will do variable renaming, method renaming, and class renaming. So you might have a class name, my activity, my fragment, and it all gets renamed. For instance, in this case, all of my activities and fragments, you cannot even tell what they are because they are like W5, H8, AA, 8B. What does it mean, right? It's no longer my activity or account activity, things like that. So it provides you security in case somebody tries to decompile and reverse engineer your APK. And here's an example, a specific example. I created a calculator class with a method to print a greeting, and adding function and multiplying. Once I pass it through R8 on the right is what it might happen, right? Instead of being class calculator, it becomes class A. My variable greeting, it becomes just variable B instead of greeting. However, the text that I have in the string, the content in the string does not change. So anything that is in strings won't change, because otherwise your content, right, text that you're using in the app would change. My functions change. You still can kind of read what they do, right? It makes sense when you look at the return statements, but it's much harder to understand. However, one of the downsides of R8 is that if you're using reflection, that's going to break your app. So for instance, here I create a class, my class, and I have a method, again, with a string, and a function that prints my method. So here I'm calling that class using reflection, and by reflection, you're calling that class with the string, as a string like that. My package name, my class, and the function, my method. I'm calling them as a string. So for what I showed you before, once I execute ProGuard on my class, it got renamed, so it's no longer calculator. So I'm here calling my class, my method. That already changed, right? Like my class changed to A, and for instance, in this case, and my function, my method changed to just the letter C. So if I were to call this using reflection, I'll get a class not found exception and a method not found exception, because those methods had been renamed. They no longer exist as I'm calling them. So for that, you need to use and understand how to use the ProGuard rules. And you may be familiar with them. Anytime you create an Android project, the ProGuard rules are created there. And for instance, we have here the ProGuard rules.profile. And you can use it to set rules of what not to obfuscate and shrink and remove. And here's an example of how you can use some of the rules there. For instance, if you're experiencing crashes in your app, or for reflection or other reasons, you can just investigate where the crash is, and you can use the keep rule to prevent that class from being shrunk, optimized, or obfuscated. So, and the syntax I showed there, keep the class. Often this can be misused, and I have made that mistake too. Sometimes it's just hard to figure out what the problem is, and I just do like, I seen keep wildcard, right? Like all classes and all methods there. That's not ideal, because it's not going to shrink your app. We also have other fancier ways to do it. We have keep class with members. So this rule will prevent certain members inside the class from being obfuscated and shrunk. There's also there's a third and final rule, which is keep classes with members. And using this will prevent classes that contain certain members from being removed, right? So you have many options to make it as optimal as possible for you. And the libraries we bring into our app also include their own ProGuard rules. So for instance, I looked at retrofit, and when you bring retrofit into your project, it uses the same rules that I show you. Keep class, they're using the wildcard symbol, keep classes with members. So it's again, very nuanced usage of ProGuard rules. And in general, R8 is capable of significantly reducing your app size. Here's, again, I brought another case study. This one is from Google, from the Google I/O app from 2019. And the original file size of the app was 18 megabytes. Once they applied R8, it became 6 megabytes. They went from 150,000 methods to 45,000, and from 3 DEX files to 1. And DEX files, I think the limit is around 65,000 methods, so that's why they had 3, because they had over 150,000. So now they have less than that, and they only need 1 DEX file. So ideally, try to use R8. It's a very easy way to reduce app size. And now I am here to tell you a little bit about Google Play feature delivery. And feature delivery is a feature of the Google Play SDK that will help you reduce your initial download of your app. And it works, it has 2 options, conditional and on-demand. Conditional will happen at the install time, and on-demand delivery will happen later on. So you can purposely call on for on-demand delivery for your app. It will, and in general, all of this will reduce your app size, but just delivering what your user needs and when they need it. And I have a personal experience with conditional delivery. A few years ago, I was working on a project for the National Science Foundation, and I have a free app on the Play Store. It has a few million downloads, a niche market dealing with sensors. I have a lot of users in the developing world. And I created an AR module for the app, and that was going to add about 5 megabytes to my base download of about 10 megabytes. So I was going to increase my download size quite a bit when I brought in my AR module. And one of the challenges I had is that at the time, and still now, AR Core, the framework that I was using for AR, was not compatible with all Android devices. So not all of my users would benefit from these 5 megabytes of data. So I decided to use Google Play conditional delivery to solve this issue. I updated my manifest. I added a new condition. The condition I added was for the hardware camera. Does the camera support AR? I added it. And then with that simple change, at install time, Google Play will verify, does this user have a camera that supports AR? If they do, they will deliver the entire 15 megabyte download size. If they don't, they'll just get the 10 megabyte download. Here, I opened a split APK that I got from the Play Store for my phone that I mentioned, the C Fold 4. The AR module is there, but had I opened this from a different phone that didn't support it, it wouldn't be there. The other way that Google Play helps you is with on-demand delivery. And with this, you always reduce the initial download size of your app for all users. And then users later on can request additional features from your app that were not implemented in the base download. And you can call this the download of those additional features the moment your app is first launched. You can download it in the background. And for that, the manifest changes instead of unconditional that I had before is on demand. And on your app, you can just add a little bit of code to whenever you are in a flow that the user is going to need that additional module, you can call it. You can call the download the split APK, and you get notified with a very simple success listener. And it fails, you also can get notified. But the amazing feature of this is, for instance, if you're using this for like an onboarding flow for your user, you can download it, let the user do the onboarding, and once they're done with it, you can uninstall the APK that you install. So you can save the user's space and return that space storage in their phone to your user. So that's how you can use Google Play on-demand delivery to reduce your initial app size. And finally, I'm going to talk a little bit about how you can track the size of your app over time, how you can keep monitoring what changes go into your APK and why is it increasing in size or not. And you can do this multiple ways. You can do it using custom scripts that will warn you about the app size increases. You can use Android Studio APK Analyzer to identify what is occupying the space on your app and how you can make gains. You can also use the Google Play Console to see your install size change over time. And you can also use other third-party tools, like Emerge tools, to gain insights into your app size increases and the causes. So here I am. Here's a script that we use on Xfinity. It's a very, very basic script that we have in our CI. And the script just checks our app size. And if the APK size exceeds a limit that we set up, we get a warning and the build fails. Because as I mentioned before, Google Play has a 150 megabyte APK size limit. So we always want to be way below that, and we want to be alerted if something made our app increase and pass that threshold. And the script is, as you can see, very simple. Essentially, if it's less than 130 megabytes, it's all good. If it's higher than that, alert us and fail the build. You can also use other third-party scripts. We've been exploring this amazing script from Spotify. It's called Ruler, and it's a Gradle plugin that helps you analyze the size of your app. It displays how much each module and dependency contributes to your app size, and it creates a wonderful HTML report. And this is particularly dear to me because I work at a very large organization. Comcast, I think, has 180,000 employees. So we work in many organizations. So other teams provide code to the code base, so I don't have visibility into everything there. So you can create with this script, assign to teams certain modules. For instance, the cameras team can have a module there, and you can name it, and you can visually inspect what each team assign ownership and see and evaluate how much they are contributing to your app size. The next tool I have to show you is APK Analyzer, and that's included within Android Studio. You can access it from the build menu and go to Analyze APK, and it gives you a visualization of your APK's layout, including what's code it's being code, resources, and raw files that you have there, and how much space they occupy. You can also inspect DEX files, which is the compiled code that it's in your app. You can also get a visualization of the file size in that beautiful chart form that I'll show later. And here it is. So you can just go and grab your APK and see what each occupies there. And in most cases, you'll see that whatever is at the top with the the orange bar is what is occupying the most space. In general, it might be classes, also closely followed by resources, which is again, all the images. And you can see also your dependencies and how much they're contributing to your app size. You can also use the APK Analyzer to compare two APKs. So you could compare your previous release to your next release, and it'll give you the diff and how much it changed each part, like classes.dex and assets particularly. So you can see what changed and make adjustments based on that. Finally, before I move on, the next thing I want to show is the Google Play Console. Many of us use it all the time, and it also has wonderful visualizations of your app download size. For instance, it shows me, this is for my personal app, that my personal app for my reference device is 9 megabytes, and how I compare to my peers in size. So it's a good inspiration to know if you need to be pursuing smaller to try to match what your peers and competitors are doing. It also gives you great tips on how to reduce your app size. And again, it's the things that I talked about. This is for my personal app, and I made a PR immediately after this, but I was still using PNG, and you can see that it's flagging me there. It's telling me you should use WebP for your images, and you can save about 8%. I am using language configurations. I'm using screen density images. I'm using app bundles, and I have R8 enabled, so I have those wonderful check marks. It also, you can look at your app size over time. So this is my personal app and how much the app size has increased. It's a good visualization, but again, a lot of this is very tedious work, manual work that you have there. It's just toil work, right? Somebody has to be there proactively monitoring it. So I found this amazing tool at DroidCon New York, Emerge Tools. They provided a free demo for me to try out, and with their tool, it's a paid tool, but it's amazing. You can see here's from one release to another. It's essentially a way better version of the APK analyzer tool of a diff. You can see what changed, what increased, and what decreased. They also provide this tool that is an X-rate, so you can see inside your APK. And here I shared a universal APK, so it has the assets for all resolutions. And it flags things like assets that are too large, duplicated assets, so the red, the red images there, the red squares and rectangles are duplicated assets that are somewhere else. So it gives you an amazing visualization for you to see what changed. And it gives you some wonderful hints. Tells you, you should be converting these files to WebP, you should optimize them, remove them, all of that. So that's about it. I hope that you learn a lot on how you can reduce your app size. And let me know if you have any questions. Thank you very much.